Hello everyone, we are looking at lesson 2.8 and in this next session of unit 2 we're going to be looking at inequalities. So instead of an equal sign we're going to be seeing less than, greater than, less than or equal to, and greater than or equal to. So let's start with the warm-up. It says please plus it says press play to watch the animation and write a story about what you see. So I'm going to hit play on the video. And we're just noticing what happens. Perfect. And so just based on what you see here, write a story. What happened in that video? If you were to explain the video to someone else, what would you say happened? Take a second to do that now. Pause the video, and then when you're all set, move to slide 2. And on slide 2, it says Desmo's Pizza is now offering delivery. It takes 15 minutes to prepare an order and then 3 minutes to drive each mile. How long would it take to deliver each order? So the first order is going 2 miles. So we're going to do 15 minutes because that's how much it takes to prepare the pizza. And then 3 minutes to drive each mile. So we're going to do 3 times 2 since we're driving 2 miles. 3 times 2 is 6. So we have 15 plus 6, which gets us 21. There's the pizza prepared. Now it's driving. In 21 minutes it's there. Perfect. Let's try another one. This one is 4 miles away. So it still takes 15 minutes to make the pizza. And then we have 3 minutes for each mile. And here we have 4 miles. 3 times 4 is 12. So we have 15 plus 12, which is 27. There's that 15 minutes for the pizza. Now it's on its way. And it has arrived. Beautiful. Let's try one more for 8. 15 minutes plus 3 times 8 since we're driving 8 miles, which is 15 plus 24, which gets us to 39. There's our pizza being made. And then we're driving and it's delivered in 39 minutes. Perfect. Make sure to have these plugged in and then push to slide 3. It takes 15 minutes to prepare an order and 3 minutes to drive each mile. Here's Mariana's work from the previous screen. 15 plus 6, 15 plus 12, 15 plus 3 times 8. Write an expression for the number of minutes it would take to deliver a pizza X miles away. So each time we did the same thing. We started with 15 and we added 3 times the number of miles. Now this number of miles that we have here is just X miles. So we're just doing 3 times X. And when you do that, you can see that our 21, 27, and 39 are all correct and works with that equation. Beautiful. Slide 4. 30 minutes or less. It takes 15 minutes to prepare an order and 3 minutes to drive each mile. Desmo's Pizza wants to deliver in 30 minutes or less. Which inequality represents that situation? So our expression was 15 plus 3x. So they want this whole amount of time to take 30 minutes or less. So they want pizza delivered by 30 minutes, which means we want all of this to be less than or equal to 30. It can take exactly 30 minutes, or it can take anything less than 30, 29, 28, 27, all the way down to 1 minute. So we're going to choose that inequality, and it says show or describe all distances they can deliver to in 30 minutes or less. Ooh, okay. So obviously that can't work for every situation because some places are going to be too far away. But we can look Well, actually, I'll do it on the board here. If we have 15 plus 3x is less than or equal to 30, we can subtract 15 on both sides. And what we're doing here is just solving for x. 15 minus 15 is 0. Bring down that 3x. 30 minus 15 is 15. Excuse me, sorry. This is 3 times x, so we're going to do the opposite and divide both sides by 3. And then we get x is less than or equal to 5. So this means x, I can hit this keyboard button to get less than or equal to 5 just to type that all out, which means that it can deliver in 30 minutes or less if the house is 5 miles or less if away from the pizza shop. So as long as it's 5 miles can be the maximum that it can be far away from the pizza shop, that it will be able to get there within 30 minutes. Beautiful. Let's go to slide 5. Here is how Mariana and Camilla figured out all the distances in which the pizza could be delivered in 30 minutes or less. Discuss which strategy is helpful. So Mariana made a table that says if it's 1 mile away, it'll take 18 minutes. 2 miles, 21. 3 miles, 24. 4 miles, 27. And then they got to 5 miles is 30. So at this point, they know, okay, we can't go any further than 5 miles away. That's going to be our maximum. Camilla did it like we did, where they took the equation and solved and got that the furthest distance is going to be 5 miles away. So for Mariana, it's really helpful to see how distances less than 5 miles are going to be less than 30 minutes. And this strategy worked, but it took a little while to get the answer because we have to plug in all of those miles to figure out what the minutes are for 1 through 5. The equation is helpful because it only took us 2 steps to solve it. Right? It's pretty quick. But this also only tells us the furthest distance away. We're not seeing all of the distances before it. So just kind of looking at the differences between the methods to solving this situation. Let's look at slide 6. It says a large pizza is $12 and toppings are $2 each. Mariana can spend as much as $20 on pizza. So that is the maximum, $20. She does not want to spend more. If X is the number of toppings, which of these inequalities represents the situation? So no matter what, we're paying $12 for a large pizza. It doesn't matter what we get on it, that's how much a large pizza is. Then we're going to add the price per topping. For 1 topping, it would just be plus 2. For 2 toppings, it would be plus 2 times 2. For 3 toppings, plus 2 times 3. So our expression is plus 2x. And the most that she can spend is $20. So that has to be less than, or it could be equal to $20. There we go. So it says show or describe all the numbers of toppings that she can get for $20 or less. So again, we can think about making our equation and solving this. So we would subtract 12 on both sides. And we get 2x is less than or equal to 20 minus 12 is 8. And then divide both sides by 2 to get x is less than or equal to 4. So she can get up to 4 toppings on the pizza, but cannot get more than that. Beautiful. So that means that Mariana can get 0 toppings, 1 topping, 2 topping, 3 topping, or 4 toppings. Let's look at slide 7. It says a constraint is a limitation on possible values in a model. Here are some examples of constraints. It wants to deliver in 30 minutes or less. Mariana can spend as much as $20 on pizza. Desmos wants to sell more than 50 pizzas per day. What is a constraint in your life? What is something that you're limited in? Maybe it's the amount of chores you have to do, or how many hours you want to sleep, or how much practice or how much reading you want to do. Some type of limitation that you have in your life. What is a constraint there? Think about that and then go to slide 8 when you're ready. On slide 8, we're talking about Trampoline World. It says Jameer is planning to host a party at Trampoline World. And it says discuss what constraints might Jameer think about when planning this party. So Trampoline World parties, it says $80 flat fee, $50 per hour for the large room, and $30 per hour for the small room. So some constraints that could come up is how much money they want to spend, right? Maybe there's a budget that this person has to planning a party. Also, these larger small rooms are per hour. So how many hours are they going to rent it out? Maybe they only want to do it for at most 3 hours, right? Another thing is there's this small room and large room. So how many people are allowed in the small room versus are allowed in the large room? And then also how many people are being invited. So these are all different types of constraints that Jameer needs to consider when planning their party at Trampoline World. Let's go to slide 9, and we're gonna do some sorting here. Okay, so it says hosting a party at Trampoline World. This is our information, $80 flat fee, $30 for the small room, $50 for the large. Match each constraint to an inequality where X represents the number of hours for the party. One inequality will have no match. Okay, so one is going to have no match, that's an important, and then X represents the number of hours for the party. So let's look at the first one, which is Mariana's party in the small room costs at most $140. So if we're looking at the small room, we have the flat fee of $80, and then we're using the small room, which is $30 per hour, and it's at most $140. So we have 80 plus 30x is going to be less than or equal to 140. Perfect. Amoli can spend up to $140 for a party that uses both the big and the small room. So Amoli is renting out the big room and the small room. So we still have 80, but then we need to consider the price for the small room and the big room, which adds up to 80. So we have 80 plus 80x, and the most they can spend is 140, so it has to be less than or equal to 140. The last one is the owner wants to earn at least $140 for a party in the large room. So we're using the large room, which is $50 per hour, and they want it to be greater than or equal to 140. They want to make more money than that, hopefully, but at the minimum, make 140. And this is the inequality that has no match. Beautiful. On slide 10, you are going to be writing your own inequality. So it says Jameer can spend as much as $155 for a party in the large room. Write an inequality to match this new constraint, where X represents the number of hours for the party. So $80 flat fee, that's how we're starting, because no matter how many people are there, what room you're using, or how long, you're always paying $80. Then we also, they want it in the large room, which is $50 per hour, so 50x, and they can spend as much as $155. So that's the most that they can spend, so it has to be less than or equal to 155. Beautiful. Okay, check out part 2 of the